Welcome. My name is Juan Manuel. This is Mario Vasquez, and we will talk about Openshift in a disconnected world. This is a very dark world. This is usually difficult, and yeah, we want to take a look to the documentation first because it's really difficult. So these are the slides. If you want to take a look, are published already. So yeah, this will be the agenda we have, and we have, we will talk about the helper node, what it means, what is the main things that should live there, the process in order to sync all the images to the internal registry, the networking planning, also the validation of the install config file, well, disconnected operator lifecycle manager, Openshift deployment, and then a quick demo. So I will let you hear with Mario Vasquez, and yeah.
Okay, thank you, Juan. All right, so the first thing that we're going to see is a look at the prerequisites that we need to have in place when we want to deploy an Openshift cluster in a disconnected IPv6 network. So we can differentiate the different prerequisites into mainly 4 groups. The first group is the mandatory services that need to be in place in order to run an Openshift disconnected deployment. Then we have, the first group is the services that we need to run an Openshift deployment. Then the second group is the mandatory services required for a disconnected deployment. Then we have a third group, which is the services mandatory for a IPv6 deployment. And finally, we have some optional components. So we will take a look at those in the next slide, but let's review here quickly what those services are. So first, we have the DNS service. Of course, we need DNS records in order to deploy Openshift. Depending on the deployment model that we will use, Juan will talk about that later, DNS records will be required for installation or not. But in any case, DNS records will be required for interacting with our cluster at the end. Then we want to have NTP service. This is really important when we are deploying the cluster. One of the first things that will happen is that the etcd cluster needs to form the quorum, and we need NTP in place. Otherwise, we can get some issues when NTP is forming its quorum. Then we will need a pull secret for those of you that are already familiar with Openshift. Openshift distributes the installer image, which is at the end image of container images in our internal registry, and you need a pull secret to access those images. So when you log into the cloud.reha.com, you will get that file. It's a file with some credentials that you need to pull images required for an installation. Then, if we want to run a disconnected deployment, we need some place where we will store those images, those container images. We usually call that the internal registry. That's just a container registry that you run on your infrastructure. Then we need an internal HTTPD server. As you know, well, in case you don't know, Openshift uses Red Hat CoreOS as the base operating system, and we will require to have some mirror of those operating system images on an internal HTTPD server. Then finally, we need a DHCP server. And then for IPv6, we will need 2 other services, which are RadBDB, which is used for sending router advertisements in our case. And then we use HCI proxy for running IPv4 to IPv6 translations. If you are running your deployment in an internal network which is IPv6 routed, and you can access it from your laptop or whatever, you don't need this HCI proxy. But in case that, for example, your internal network is routable in IPv4 and you're deploying in a disconnected IPv6 environment which is not routable, you can use an HCI proxy running on both networks, and that's how you do translation mainly. This slide explains what I just said. And then we have some prerequisites that needs to be applied on the helper node. By the way, I haven't talked about the helper node. So we call helper node a node running in our infrastructure that will provide some of those helper services. And by the way, if, for example, you already have a DNS server in your infrastructure, a DHCP server in your infrastructure, an existing registry, all that stuff, you can reuse those. So in case you don't have those in place, you can always refer to this documentation and deploy a helper node that will run those services for you. In case that you're running those services in this helper node, you will need these ccTL settings. You have maybe the definitions of those settings here. Since we don't have too many time, I will go a bit fast and skip this section, but you have the settings there. Then, as we mentioned, there are some prerequisites that need to be in place when you deploy the cluster. We have talked about the DNS. In this slide, we are basically defining that we need at least 3 records. For the ones that are familiar with Openshift deployments, you already know about them, which is the API record, the API int record, which is the internal registry, the internal record used by the Openshift installer, and then the ingress wildcard, which is the ingress endpoint to your applications deployed on Openshift. Then NTP, as we mentioned, is mandatory for multi-node deployments. If you're deploying a single node Openshift, which is something new, by the way, then NTP is not mandatory. And then, as we mentioned, pull secret will be required for getting access to the images. And with that, those are the main prerequisites. And then we are going to showcase, more or less, an Openshift deployment. So the first thing that we need to do is we need to have our internal registry, as we mentioned. So in these slides, we are basically creating some certificates that then we will use in our internal registry. We need the registry to be exposed in a TLS way. So we are here basically setting some certificate settings. One important thing here is that you want to set up this subject alternative name. Otherwise, some installation phases will complain about the certificate not being recognized. So if you set that setting, you're okay. If not, you need to export an environment variable, which the installer will output. Like, okay, I cannot continue. If you want me to continue, you need to export this envar. Then we need to run the internal registry. As I mentioned before, if you already have a registry in place, you don't need to do this stuff. But if you don't have one, you can use, for example, the Docker registry, right? So in this case, we are using Podman to run that registry. We're basically setting some environment variables where we're saying, okay, we want this path, we are going to use these certificates, and we are going to use this config file. One important thing, if you're using this Docker registry, is that if you plan to use operators on a disconnected fashion, some of the operators have images, container images that are created with the schema1 image. So you will need to enable that compatibility in the registry. Otherwise, when you are running the OLM image mirror, some images will fail because the registry will not support that schema v1. Then, more things. Now that we have our registry in place, we need to mirror the Openshift release image. The Openshift release image is like a big container image that points to other container images. For example, the Openshift release 4.8.10 will point to the cluster, the authentication operator version, whatever, to the Openshift registry version, whatever. So it's like the way that we have to release Openshift. So how we do a mirror of that image? It's very simple. We need to set some envars, but basically the main ones that you want to set up are the OCP release. Here's where you define which release you want to mirror. And then if you are using a proxy, you can set up these ones. If not, that's not required. And then you are basically pointing to your internal registry. In this case, we are using hostname and port 5000. In case that you have the registry running somewhere else, you need to basically configure the hostname for your registry. And then again, the pull secret, etc. And then we have the OC command line tool that has built-in mechanisms to run the image synchronization. So as you can see in the command below, it's as easy as running OCAVM I want to run a release mirror. I'm mirroring from quay.io, whatever, to my local registry, okay? And to the release image, whatever. So basically, you're defining what are you getting from Quay and where are you putting that on your internal registry so you can consume it later. Next thing that we need to mirror is the Arcos image. As we mentioned, Openshift uses Red Hat CoreOS as the operating system, and when you're running a disconnected deployment, you will need to grab those images from an internal location. So what we are doing here is basically, first, we are going to extract the installer, the binary. So Openshift has its own installer binary, which is this one. Openshift, in this case for bare metal, it's Openshift bare metal installer. If you are deploying a cloud provider, it's Openshift install, for example. But anyway, what we are doing here is we are getting this binary from within the mirrored Openshift release. And with that binary, then we can use some options for the binary, like CoreOS print stream JSON. And this sub command, what it does is it gives us which Arcos image is used by this specific release. And then that will give us a URL, and that URL is what will be what we will wget, so to speak, into our HTTPD server, and then we will reference those images back in the install config. Juan will talk about that later. What else? Okay, yeah. Then we come to the prerequisites in terms of networking. As we mentioned, if we're going to work in an IPv6 deployment, we will need several things. The first one is DNS mask and router advertisements. If you're familiar with DNS mask, you might know that you can send router advertisements using DNS mask, but that's not, we don't recommend that because sometimes it takes a bit for DNS mask to send those router advertisements, and we have found issues when using DNS mask for that, so that's why we use RADBD. Then next things that can be tricky are Slack addresses. If you don't plan to use Slack addresses, which is the way that IPv6 has to auto-configure network interfaces without DHCP, we'd recommend you to disable those Slack addresses. Otherwise, when the node boots and kubelet starts, it will get the Slack address most of the time as the address where it needs to listen, and you will get issues with that. So if you plan to use the HTTP/v6, you need to disable Slack addresses. Then next point will be, are we going to use Pixie or are we going to use virtual media? So if we are going to use Pixie, there are some other stuff that we need to keep in mind that we will see later. And if we are going to use virtual media, there are other stuff that we need to keep in mind. And finally, we need to boot our servers, our hardware, and depending on what we need, we will need to use UEFI mode or legacy mode. I already talked about DNS mask and router advertisements. That was why we used RADBD. If you want to check the router advertisements in your network, you can use this tool, NDP tool monitoring, and then you can define an interface address connected to your IPv6 network, and then the type of message that you want to filter, in this case, router advertisement. You should see those coming from your network equipment if you're sending router advertisements in your router, in your networking equipment, sorry, or you should see those coming from the RADBD if you are using RADBD. Slack addresses, this is what I already told. If you are not going to use Slack addressing, disable it. That will help you. That will probably help you with the deployment. Then Pixie versus virtual media. We have in one side the Pixie method, which requires another layer 2 network. This is usually not something that we can do at most customers, since there are different security mechanisms that don't allow to run Pixie servers on those customers. So we usually recommend going with virtual media, and as a rule of thumb, Dell and HP hardware works best for virtual media OpenShift deployments. Then UEFI versus legacy. there are a couple of scenarios where you want to use Wi-Fi. For example, if you plan to use NVMe drives, you need to use Wi-Fi. And then there are some VMCs that if you want to run PXE booting over IPv6, you will need to boot in Wi-Fi mode as well. And with that, I believe that was a lot. I hope it was clear, but now I will hand it over to Juan, who will walk us through the install config file.
Okay. Install config file is the main file that we will use to deploy Openshift. This is like a configuration file that we will define in order to put all the things together. So let's start from the beginning. We have the network type. For now, we have two network types, Openshift SDN, which is I think, for now, the default one for IPv4. And then we have the OVN Kubernetes, which is the default and the only way to work with IPv6. So this is the way we work. So machine seeder is the addressing range, network range that we will use to work with Openshift, the Openshift deployment. So this is the range that we will use to work in the end with the egress and ingress addresses. Then we have the cluster network address, which will be all internal. This is not a matter of I will ask for a new address for the networking people. No, it's not necessary. This will just for internal communication, and also the service network. One thing that should not be overlap between themselves. Should be different ranges. So with that, the metadata name we will use for, let's say, the name of the cluster. Well, the name of the cluster. Yeah, name of the cluster. Then the compute, the number of the worker nodes that we will have on our cluster. In our case, 0. That's okay. And the control plane, in this case, it's three replicas because the deployment will be based on 3 nodes. If we want to deploy SNO, I don't think that it's supported already, but it will be. And the replicas should be set to 1. Next section will be platform bare metal. Here we have 2 options. In the past, we just 1, but for now we have 2 options in 4.8. If I remember correctly, also 4.7. The provisioning network is not necessary at all if you will work with virtual media. So you can disable the third free options with another one, just to put in provision managed to know or something like that. You can check it on the documentation. But basically, we are configuring here the name of the interface that we will be used for the provisioning network on the helper node. Then the machine seeder that will be used for our provisioning network, and then the bridge name. Then let's go with the external bridge, which is the, let's say, management network. So yeah, we just need to put the name of the interface that we will use on the network. And Bootstrap provisioning IP, this is the IP that the Bootstrap node will be used. Bootstrap node will be something like a virtual machine that runs on the helper node. It lives on libvirt, and yeah, it will take that IP. The Bootstrap OS image and cluster OS image are a couple of images that you will download in a step before that Mario already showed you with the Coreos GStream, whatever. It's extracted from the release, the OpenShift release. And you just need to put the name of the QEMU and the OpenStack image hosted from the internal server. And also, it's mandatory that the SHADA 256 matches with the release. If not, it will fail. Then a couple of important things, the IPI BIP and the ingress BIP. The IPI BIP is where the IPI of OpenShift and Kubernetes will live. And the ingress BIP will be more for the application that are deployed on top of OpenShift. So yeah, this should be set in a previous step on the prerequisites. Hosts are, let's say, the bare metal nodes, and here the description of everyone. The name of the VM, the name of the host, the role that it will take on the cluster, the VMC access, which involves the IPMI address. It will be used also with the Redfish interface. And username and password. This is quite easy. And the bootmap address, because in API installation will be set mostly with API, with Pixie. And then you need to put the bootmap address where the Pixie booting will be executed. And the hardware profile, usually it's set to default because this is the most compatible way to work. So you have more of them, but you can check it on the documentation side. What more? Yeah, a couple of, well, actually 4. Image content sources. It involves one thing that I will explain later, but long story short, when the runtime of every node, in this case Cryo, tries to go to the external registry, in this case Quay or Red Hat registry, the runtime will take in account that you have some kind of proxy at some point in some place, and it will try to go, not a proxy, sorry, mirror. Then it will go first to that mirror, and then if the mirror doesn't have that image, it will go to the outside image registry. This is the what image content source is on this config file. Then the additional trust bundle involves the TLS certificate that we already configure in our internal registry. The pull secret is our credentials that will be used to download the images. In this case, it's a matter of put the authentication that we already set on our internal registry. It's mandatory to have TLS and authentication on our internal registry, so take that in account. And the SSH key that will be injected on the Bootstrap VM and also on the destination nodes. Because if you have some kind of issue during the installation, you can SSH into that node and check what is happening. So let's go with the catalog sources. This is the big thing. Catalog sources, this is a Kubernetes object that is used mostly by operator lifecycle manager. This operator lifecycle manager is an operator that lives in every Openshift deployment. And it mostly have a database inside. Well, it's like SQLite, and contains like a number of packages, package manifest, which is called, and like more of like 1 to n number of package manifest, and you can contain many of them. So this is an example of a catalog source. We call it Custom Community Operator Catalog version 4.8. The namespace is Openshift Marketplace. This is mandatory. And the image is pointing to our internal registry. This is very important in disconnected deployments, because if not, it will try to go to the internet and download the image that it's pointing this catalog source. The other fields are purely cosmetic. And the last one is the interval that the operator lifecycle manager will try to pull the new images from the new catalog sources, the new package manifest from the catalog source. Yeah, catalog sources, more of them. One catalog source, well, I think I already explained all of these things. So one image can contain more of package manifest, and yeah, that's already explained. So let's go how to dissect a catalog source. Well, actually, an image that is pointing a catalog source. You can run this Postman run. It will show you some kind of database, as you see. And you can use a client called gRPC curl to see how many packages have inside and what is their names. So with that, it's not necessary to create a OpenShift deployment in order to see that. What more? This is the way to create our index image internal and push it to locally internal registry. You need to use a OPM binary, which is you need to download from internet. And then when you need to set the index source, which usually points to the Red Hat one, then the packages that will be included, in this case, I put a couple of them, but you can put whatever you want. And then the tag that your image will get. So with that, you need to push it to the internal registry and then tell to OC client that needs to mirror all the catalog that contains inside of on this image. This is the last command that you see on the screen. So next thing is the image content source policies. This is more like the thing that I already told you in the index in the install config file. But this is when your cluster is live and working, and you want to set up some kind of policies in order to go first to your mirror instead of to go to internet. As I said before, it was a runtime level, so you need Cryo working on your master nodes. When Cryo needs to pull an image, it will check the registries.conf file, and it will take the mirror that are in front of the image. It's a Kubernetes object, and the controller is the matching config operator. So you need to have it in a non-degraded state. If not, the ICSP will not work. Will not apply, sorry. And this is how image content source policy looks like. This is the mirror, this is the source, and that's it. It's quite easy. The node will not be rebooted at all in the latest versions of Openshift, so that's pretty cool. And this is how it looks like in the registries.conf file. So I will need to go faster because we are getting out of time. I already mentioned this couple of things. If you modify the registry.conf file manually in a live situation with a cluster running, MCO will take in degraded state, so this is bad for you. If you decide to want to modify the configuration file manually, you can do it, but you need to know what this involves. If you apply another thing or another object that complains MCO, it will not be applied at all. So yeah, I think we can continue with the deployment. We already have the prerequisites, the install config, so let's deploy. Yeah, we have two ways, native ways to deploy Openshift, UPI and IPI mode. A UPI is user-provided infrastructure. We will not focus on this way of work, but you have all the things here, mostly of all the hubs here. So let's go with the IPI. IPI mode, it's the easy way to deploy Openshift on-premise and also on cloud. You need to provide a libvirt URL to allow the installer to raise up a VM, and with that, start the bootstrap process. You need to provide the credentials. You need to for your, the provider itself. And if you will deploy on this connected way, you need to add some more manifest. In this case, you need to add ICSP files in order to point to the right image instead of point to internet. For example, a good thing is the cron side. In this case, we put an example. With this way, the deployment will get in sync during the deployment. It will copy the install config file, it will be consumed, and then all the manifest will be copied into the Openshift folder. So, yeah. After that, the deployment is started. It will be used the last command that you see here, the Openshift bare metal install command. It will create a bootstrap VM. This VM, as I said, will live in the helper node. This helper node at some point will stop that VM because the installer already create all the things and the etcd cluster is already in consensus. So the Bootstrap VM will be erased and the cluster will the cluster will be self-installed by itself. And at some point, if you see some kind of error, you can continue with this command, as you see here, this wait for command. And that's it. The deployment should be smooth. You have a couple of alternative methods. The first one is a supported one. It lives in the SaaS, in the software as a service on cloud.redhat.com. It uses as a base a system installer and OCM, and it deploys cluster on premises and also on AWS. And also you have the KCLI tool, which is pretty cool, but it's not supported by Red Hat. But take a look. We already set a link there, so I will stop boring you with that, and I will show you a demo. Well, actually, Mario will show you a demo. So I will put this in a big screen. Yeah.
Before we start with the demo, I just wanted to say that since we don't have too many time, in this repo, which is in the slides, you can find this folder here, demo scripts, where you have 2 folders, prerequisites scripts and deploy scripts. So if you want to run an IPv6 disconnected Openshift for deployment on your own environment, this only requires a KVM host. And with that, if you run the scripts, they will take care of configure all the prerequisites, creating a virtual network and all that stuff. And then they will deploy Openshift 4 in a disconnected way for you. And that's basically the demo that we are going to see. So the first thing that we're going to see on this demo is that we are going to mirror the Openshift release. So this is basically connecting to Quay.io, grabbing those images that are part of the Openshift release that we want to install, and we'll push those container images to our internal registry. As you can see, you have a lot of uploading messages. That's basically the images being pushed to our internal registry. Next thing that we're going to do is we're going to extract the Openshift bare metal install binary from the release. And now we need to mirror the Arcos images. So that will get the Arcos images from the internet. And then we'll put those images on our internal HTTPD server. Next thing will be creating our infrastructure. In this case, we are creating empty VMs. So we are creating 6 VMs, 3 masters and 3 workers. And then we need to prepare the install config. In this case, we are using Redfish via SUSE tools. So we need to grab some VM IDs and put those on the install config. We will review the install config here really quick. As we already saw, there are different parameters here, like the Arcos images, the VIPs that we will be using, and then the VMC addresses. You can see that we are pointing to a Redfish virtual media endpoint. Then we have the image content source policies, our registry certificate, and finally the pull secret and the SSH key. And then what we are going to do is we are going to run the installation. This will create the Bootstrap VM. In the Bootstrap VM, we will run some services, a temporary control plane on top of that, and then our nodes will be boot by the Bootstrap VM automatically. They will get the Arcos image loaded. And then eventually, in those 3 master nodes, we will get an Openshift control plane running. When that happens, we will delete the Bootstrap VM. And next thing that will happen is that the control plane running on those master nodes will deploy the worker nodes that we define in our install config. So this usually takes like 40 to 50 minutes. In this case, it took longer because it was running on VMs. But basically, here we're saying the Openshift installer. Now all 6 nodes are up and running, and we are just waiting for some operators to finish the deployment. And when that finishes, we will get an install config, a kubeconfig file, and also a kubeadmin user that we can use to connect to the cluster. Okay, so here the installer gives us that information. We are going to export the kubeconfig, and then we will get the node of the cluster. We can see that we have 6 nodes. We can get the cluster version, and we are running 4.8.11. And then if we run OC get pod nodes, that's all white, we can see that those are running using IPv6 addresses right here. And so we'll do the pods and services. And with that, I believe that was it. If there are any questions, I don't know if we have time, but in the slides you have our email addresses. Feel free to drop an email with any questions you might have, or if you see us around, feel free to say hi and ask whatever you want.
Thank you.
Thank you.